Yes, so delta H is negative 186. So if it is negative 186, that is for 2 moles. So if 2 moles is 186, therefore 1 mole will be 186 divided by 2, which will be 90. This one will be negative 93 kilojoules per mole. Now let's look at our second example. Let's look at our second example. Let's look at our second example. So in our second example, which is number 2, we are told to calculate the heat of a reaction involving CH4 plus Cl2 to give CH3 plus hydrogen chloride. So this one is a substitution reaction involving methane. So the first step is to identify the bonds. We have that hydrogen, 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 hydrogen plus chlorine, chlorine to give. We have hydrogen, 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 chlorine plus hydrogen chloride. That's what we have. So now these are the bonds. So this side, bond breaking. Bond breaking, and on the other side we have bond formation. So bonds broken, we have carbon, hydrogen, carbon, hydrogen, carbon, hydrogen, carbon, hydrogen. So we have 4 carbon, hydrogen, which is 4 times. Go back to our bond energies. Carbon, hydrogen, carbon, hydrogen. Carbon, hydrogen is 413, 413. Then we have 1 chlorine, 1 chlorine, chlorine, 1 chlorine, chlorine, which is 1 times. Chlorine, chlorine is 239, 239. So we have total there. So in this case, we'll have 4 times 413, which is 1652. Then this is 239. Get the total plus 239. Now 891 kilojoules. When bonds are broken, energy is absorbed. Bond breaking is endothermic. Endothermic. So delta H there is positive. Then we come to the bonds, bond formation. We have carbon, hydrogen, carbon, hydrogen, carbon, hydrogen, carbon. So we have 3 carbon, hydrogen, which is 3 times 413. Then we have carbon, chlorine. 1 carbon, carbon, chlorine. That is 1. Carbon, chlorine is carbon, chlorine 346. 3 times 346. Then we have 1 hydrogen, chlorine. 1 hydrogen, chlorine, which is 1 times hydrogen, chlorine is, where is it? Hydrogen, chlorine bond 428. 428. So in this case, we have 346, we have 428, then we have 413. 413 times 3. 1239. So this is 1239. You add 1239 plus 346 plus 428. You have 2013. 2013 kilojoules. Bond formation is exothermic. So delta H is negative. So heat change, heat of reaction here will be simply take this, bring it down here. This enthalpy of involving bond breaking, 1891. Then bring this one here, the way it is, negative 2013. Then work it out directly. So if you do that, 1891 minus 2013, you get negative 122. So we have negative 122 kilojoules per mole. So I want to stress some points here that these bond energies, they are normally given in the question, so you don't have to cram them. 2, the first thing, make sure you balance the equation. If you are given an equation which is not balanced, then you must balance it. That is the second point. Third point, identify the bonds. As you identify the bonds, do not forget that the equation should remain balanced. Identify the bonds. In some cases, you can ignore, after doing practice, you can ignore some bonds which are not affected. Like, we have carbon, hydrogen, carbon, hydrogen, carbon, hydrogen. And carbon, hydrogen, carbon, hydrogen, carbon, hydrogen. They do not change. There are no such bonds. But for now, identify all the bonds and list them down. If you have carbon, hydrogen, list them. How many are they? Chlorine, chlorine, how many are they? Then make your calculations. Another thing that you should note is that for bonds to be broken, energy must be supplied. Energy must be absorbed by the bonds. So bond breaking energy is normally endothermic. That's why we put positive here. Then you check the bonds formed. Check the bonds formed. Now, after adding the bonds formed, make sure that you indicate the side to show that the bonds formation is an exothermic process. It's an exothermic process. So make it negative to show that heat is released. Make bond breaking positive to show that heat is absorbed. Then when calculating delta H, don't bother with the formula. Simply take this value for bond breaking, bring it down here. Then take the value for bond formation, bring it the way it is. Then work it directly. Forget about the formula. You get your answer. So that is how we work when it comes to bond energies. Use of bond energies to calculate enthalpy change for reactions. Now, I will give you more examples in our Google Classroom. Make sure that you work those examples, and if there is any problem we can discuss. I will give you more complex ones, but make sure you identify the bonds. So thank you for listening, and let us meet next week.